diagram I'm showing it along with the question, everything, that one. So this is the, I'll show some piles here. Get into problem now. This is at initially at t equal to 0. Now at any time t, there's a condition. He's asking the acceleration. So which part will be moving? The links that are on the ground. So there's a moving part, no? So shall I call this as a system? Finish over. So what is a system? So let this be a system. Now, with the time, what will happen to number of links for the in the system will increase, no? And what is the state of this? This will be at rest. This will be moving. Now, mass of system will increase or decrease. Number of links in this horizontal part, here what happened? This is the pile. In the pile will be attached. So what happened to the horizontal part of the chain will be in motion. So what happened to number of links? The links will get added up, no? The mass of system is increasing. Let me pick up this link. This is something very important. This link. Very next moment, what will happen to this link? This link from pile will enter into moving part of system. Able to make analysis. Very next part after what happened, this red color link what happened will be on the in the moving part of system, no? And what is this? Let's assume that the system is moving. That one. So this particular P, I'll call this is P, that one. So this particular link P, it is about to enter into the moving system. So let's calculate the no. This is the. I think we'll do one thing. Moving part I'll show by 1, and the part which is at rest I'll show by 1. And look at that red color. The link P will get added up to system, no? Very next moment for t greater than t, after this time, the link P will get added up to system. So what is the state of P? P will be at rest. At rest, and after some time, will get added to the system. Will get or will enter system. Anything you can write it. Will get added to system at rest, and after some time. Very next moment open, it will enter the system. So now the system is gaining mass or losing mass. So the moving part of the chain is what? System, I'm telling that one. Okay, let's calculate the VR now. So what is the method of VR? VR is velocity of P with respect to system equal to velocity of P minus Vs. Velocity of P we don't know. Velocity of P is 0. Velocity of system, let it be VR. In what direction? Towards left, I'll take it positive. Or no sir, I'll take anything directed towards right, towards left negative, towards right, let it be positive. And then what is the velocity of system? Will be towards left. Let me be the velocity of the chain. So what is the, now VPS will become VR. So what is the value of VR now? VR equal to what about direction? I got positive, no? Okay, we'll do one thing. We'll put with sign. I got here positive. Positive means in what direction the VR will be like this. Able to make it out? So this I think I'll remove it, so it'll be much easier for you. I got VR positive. Positive means what? When the VR will be directed towards right. Okay, let's come for this. VR is positive. Finish sure. So now what direction the thrust force should act on the moving part of the chain? Should act towards right. I'll show it here. This is a thrust force. Write down the equation, no? And there is also a friction. Friction due to what? Friction due to by the ground on the moving part. Let x be the length of the chain on the ground. Write down the equations now. This is a very important. Rest all mathematics. We don't know thrust force, how to calculate thrust force. What is the basic formula? Thrust force should be equal to mu, or so let me write already mu already there, no? Let me write lambda here. VR into dm by dt. This should be equal to VR dm by dt. So let me take a small element lambda dx. So this will be v lambda v, or lambda v square. Look at this thrust force. The same method like previous problem what I did, the similar thing I'm bringing it, lambda v square. Let's write equation now. F naught minus friction minus thrust force equal to ma. What is m? Mass of this part of the chain. What should be the friction? Mu k into lambda x into g. Lambda x is mass of this part of the chain, or thrust force is lambda v square into me. Let's write one more equation. F naught what is m is equal to lambda into x, no, in g. Lambda v square equal to lambda x into a. Able to analyze? Just asking acceleration as a function of speed as well as distance. So there's a basic formula. Lambda is dm by d. dm by dt is what? We can write lambda into dx, that one. What is lambda? Lambda is mass per unit length. I'll write it nearby here. Lambda equal to so very generalized way. So I think it's all about writing equation anybody can write, but initially what is the system, mass getting added up or mass being taken out from the system. This is what you have to make it here. We can't solve. This will be very lengthy mathematics is there. So just only acceleration as a function of x and v. This is one basic equation. Now, what about the? Will there be any friction on the pile? I'm asking some very good thing here. Will there be any friction on the pile? Thrust force is what? On the system. So equivalent opposite force should also act on the pile. Now look at the pile. The mass of the system is decreasing. No? So will there be any thrust force will act also on the pile? Yes, it will act here. So you look at this particular P now. So it is the moment it's get added up, what will happen? It was at rest, then come into motion, that one. So will there be any thrust force on the pile? Instead of this as system, let me take this as system. In that case, what happened? This particular will be at rest the moment it's get added up. it will be ejected here now. Now, what is the velocity of this will be in this direction. So then, what is the velocity of the ejected mass with respect to pile you calculate. Then get the relative velocity. Then system it's losing mass. Then get the thrust force. Please do analyze here. I may ask you like a more than an option. No friction will act on the pile. No, friction will act on the pile also. There will be thrust force will also act on the pile. So identifying what is system is what the major part of the discussion here. I think now it has you are in a far better position now. You can take any random question, define what is the system, in what action the mass is ejected, then get into the problem. Then this is about laws of motion, nothing to do. Calculating thrust force, problem to problem will be different. The first case is directly they give mu and all that particular thing. So here for a chain, this is a method, calculation of thrust force. So different types of systems will come where the calculation of thrust force will be, this is a basic formula. Here I took dx by dt, there dy by dt earlier. So you just be careful about the mathematics involved with the calculation of thrust force. Okay, now so tomorrow we'll discuss some problems related to some applications where I'll bring the power, work done by thrust force, all that we'll discuss that one. This is about the basic analysis today. Tomorrow we'll just focus on the work done concept also. Work done and the power involved here by the thrust force. So mechanic energy can I conserve or not in this variable mass system? So in those aspects we'll try to analyze. Okay, now I'll stop the class.
Thank you, sir.
Thank you, sir.
Yeah,
Thank
welcome.
you, sir.
Thank you, love you.
Thank you, sir.
Thank you, sir.
Can we conserve momentum net force on the system? See, like, what is the system you define? If you define system as this horizontal part, so tell me net force is non-zero, no? What is the momentum conserve? When you take this total as system, then also this force is acting. So where's the question of momentum conservation? So like, what is the situation based on that you have to check it. Today I'll respond. Today I'll respond. Today I'll help you. Okay, thank you, all of you. Take care. Bye. For chain, you can take help of this one. If the provided chain is vertical or horizontal, you have to take help of this formula. Lambda v square only it will come for the chains. Okay, thank you, all of you.
Thank you, sir.
Thank you. Take care. Bye. See you.